Hello, sir. I'm Mayank Patel. My PSID is 2007512. I'm here to present Chennai water scarcity analysis, future prediction of rainfall and reservoir levels into the subject, which is data analysis and construction management. My agenda is a proposal first of all, the project proposal, second methodology, and it includes existing data analysis, and finally we are creating two different profit model to predict rainfall and water reservoir levels. And basically the project is all about the city Chennai, which is located into the south part of the India, which serves a major role as a financial capital into the South India. Basically, we have nearly 50 cities in the world which are facing acute water shortage in the current days, and Chennai is one of them. So this is due to 2 years of inadequate monsoon seasons and increasing urbanization that caused some encroachment on the water bodies in and around the region. There are basically main four water reservoirs which are major source of the water in Chennai, which is Pundi, Kulavaram, Red Hills, and Chembabakram. The report discusses the major causes of water crisis while analyzing water levels of four main reservoir levels and rainfall levels into the region. We are attempting to find a relation or a trend between reservoir level and the rainfall by using machine learning model, which help us to create a profit model to predict a future rainfall and reservoir level. Methodology. Our data of rainfall and reservoir level are mainly in ascending order from 2004 to 2019. So time series analysis will help us to extract meaningful statistics and characteristics of the data. Also, to help us to identify the current trends and connections between rainfall and reservoirs, where profit is the procedure for forecasting the data based on active model and additive model when non-linear trends fit with yearly, weekly, and daily seasonality. It also works based with the time series analysis, and it is robust to missing data and typically handle the outliers as well. So we are making profit model to help us predict the future rainfall and water reservoir level in Chennai. uh, Data description. So basically our data includes 5 column and nearly equal to 6,000 rows. First of all, from the raw data, we need to procedure the data, and we need to convert the data into the form of graph and histogram, so that which we can see we can identify any trends, or we can see any seasonality into it. So basically, we are first of all we need to import different libraries, and then uh, we need to read our input files and sorting our values into ascending order, so that we can process the data further. We are just checking the heads of the data, that because it's important to know the data are in the current format which you inputted to get some result, because otherwise you will get some faulty result or some unusual result. After that, we need to check the null values of the data to avoid the faulty result, to prevent from faulty results. Here we are describing the reservoir level and rainfall level. Basically, we are getting the statistics of two different statistics for rainfall level and reservoir level, which includes mean, standard deviation, minima, and maxima. Here now we are analyzing the existing data. Basically, we have a very large data. Here we are taking initial look to the rainfall and reservoir levels in the Chennai over the period of time visually. This visual will give us a better understanding of our large data. We can see that rainfall and reservoir levels are tied to each other. from the above visualization, we can confirm a visualization that Kolaram confirm from visuals that Kolaram does have low reservoir levels given the rainfall levels. Now we are checking the excuse me. Now we are checking the levels by plotting the histogram. Firstly, we can clearly see reservoir levels decreasing from histogram. We can see the trend that all the regions are having worse result than the previous years. Kolavaram and Pundi have a very low mean reservoir level than any other region. Secondly, it shows that a year 2018 had lowest rainfall in the recent years, which is one of the noted reason for drought of water that was occurred in the Chennai. Moreover, most of all previous years has lowest difference in rainfall. Let's take a look at the aggregated rainfall, then individual rainfall across the region. This histogram shows rainfall level, aggregated rainfall levels. In the aggregated rainfall histogram, we can clearly see lowest rainfall into the 2018, also low amount of rainfall into 2014 to 2000, 2012, 2014, and 2016. It certainly does shows that February 2019, the Chennai has a very lowest reservoir levels, less than any year other than 2004. This is the actual evidence of the drought. We need to visualize reservoir levels per day based on the seasonal information now. So we have plotted aggregated reservoir levels in the Chennai per day and assigned a different color to identify the seasons. Here are the three seasons. Blue is the normal season, green is the monsoon season, and red is the dry season. Here, often during the dry season, we find decreasing water levels, although this continues until the monsoon, until the monsoon season starts again. We can see that 2017 monsoon season has no impact on significant increase in reservoir level, and in 2018 the dry season depleted reservoir to crucial levels. Also, during 2018 has the season of monsoon season of 2018 has no impact of providing rain to the Chennai. There is no relief from monsoon 2018. Um, So we are making a scatter plot of reservoir level versus rainfall level to check the impact on each other. So basically, we can conclude from this scatter plot that amount of rainfall over the period of past influence the water level today. The more we aggregate, the more it looks like we can see two linear trends into the upper line from 4,000 to 10,000 reservoir level and occurring at the rainfall levels between 6,000 to 8,000, and a separate trend encompassing the result, the rest of the line. Based on everything we have analyzed, we can conclude that Chennai has seen low reservoir levels before, and it shows that they were facing lowest reservoir levels during the current dry season, lower than any other year. The analysis shows that there is no strong relation between rainfall and reservoir level, but it also shows that they are both tied to each other. They have indirect impact on each other. Now we are like trying to predict the impact of the rainfall on reservoir levels through the profit model. First of all, we are creating profit model to predict rainfall. Here we need to first import the library, and basically we need to find statistics, basic statistics of the data. We need to check the heads of the data after importing that the data is in the correct form or not. Here we need to Here basically we are resetting the index, um, because and for the better understanding of the line graph, we have to change the frequency from daily to monthly to get a smoother line graph and to understand it better. Now we need to decompose the data to check the trend, seasonality, and residue. Second graph is showing the trend, the third one is showing seasonality, and the fourth one is showing residue. We can see that almost similar rainfall trend throughout the all years basically, but from 2017-18, it hits towards the bottom. We are getting good seasonality over the period of time here. So we are preparing data. First of all, we are preparing data to import into the profit model by changing the index again, because to fit the data into profit, you need to change the index. We also need to check statistics of the processed data, and then we are fitting the data into the profit model. We are getting y hat. We are getting y hat from the parameters like y hat lower, y hat upper, trend lower, trend upper, additive terms upper, and additive terms lower. Now we are plotting the components to get forecast of the rain. Here we can clearly conclude the decreasing trend of the rainfall levels for upcoming years. It will be definitely crucial situation for Chennai. Also, the yearly line graph shows a seasonality, which shows the good amount of rainfall in the monsoon season only. We need to pay attention. The monsoon is getting shorter over here. Now we are predicting a reservoir. Now we are predicting reservoir. We are just checking the accuracy through R square and RMSE score. So our RMSE score is around 186.56, and R2 square is about like 0.55, which is equals to 56% accurate model. So now we are just checking the profit model, which predicts reservoir level. Here, like more or less the procedure is the same. We first need to import libraries. We first need to import libraries, and we just need to check our initial data. Our data includes almost 6,000 rows and 2 columns, because we are using the aggregated data to check the reservoir levels. And we are just checking the heads after importing it. Here again, we need to reset data first, and we need to change our frequency from daily to monthly to get a smoother graph and to better understanding. Otherwise, we'll be getting some faulty or unusual data. To avoid that, we need to convert that thing into monthly data. After checking the initial process data, we are here to trying to decompose the data, which help us to get some trends, seasonality, and residue of the data. So basically, second graph is showing the trend, the third one is showing seasonality, and last one is showing residue. Here we can say that there is a gradual drop in the reservoir level from 2013 to till current dates. So here we are getting y hat. It's more or less similar process to the rainfall level. We just need to change the index. We just need to convert our column name, because profit demands different index for this data. And then we are getting we are fitting our model into profit, and we are just getting y hat, which is accuracy score. um, Here we are getting reservoir level. uh, so basically our trend and seasonality of our reservoir level model. It shows that after 2013, rainfall is decreasing over the period of time, and uh, And it should be considered as a warning for Chennai people. Um, and we can see in the seasonality after monsoon, immediately our reservoir level get declining until the next monsoon hit the city. Basically, for the reservoir level, we are getting a low accuracy, which is around r to square of 0.32, which is around 32% accurate model, and RMS score of 1437. So we'll discuss this further in the conclusion. From above the two profit model, we can say that Chennai will be facing real hard time if precautions will not be taken in the direction of conserving water and improving the reservoir levels by rainwater harvesting. In our model of rainfall level and reservoir level has not strong relation between them, but it shows that they both are tied to each other. They both have indirect impact on each other. So basically, reservoir level prediction is showing the range from 1,000 to 4,000 million cubic feet, which is less accurate. The reason behind that, um, we need to include more data like population in Chennai, the number of households near the reservoir, water usage per person in Chennai, temperature day to predict more accurate model. This feature might help us to predict more accurate model, which may help cities to better prepare for drought before they happen. So thank you so much.